Section 2.3, we start talking about these things called relations and definition of a function. And there's some terminology there, but we're going to come up kind of with our own as we go. We're going to start with what is a relationship? Okay, what is a relationship? Determine if the relationship exists. Okay, up above, we start talking about a set of ordered pairs is called a relation in X and Y. The set of X values in the ordered pair is called the domain. The set of Y is the range. So what we're looking at is something a relation. And we don't use this term much after talking about it now, but one of the ways to talk about a relation is for every X, there's only one Y value. So if I come in here, for every X, there's only one Y value. Well, here X is 2, it has a Y value of 3. Here X is 2, it has a Y value of 4. Fail. So for this guy, is a relation? No. Number 2, every X has only one Y value. 1 has 3. There are no other 1s in there. 2 has 3. There are no other 2s. 3 has 5. There aren't. So yes, this is a relation. Number 3, you see that one-to-oneness. That's a common phrase, one-to-one. Okay. Every X has only one Y. So yes, that is a function. Number 4, somebody give me an answer. Is it a function or not?
Yes.
Yes, because if I gave you an X, you're only going to give me one Y value. I say 2, you say 10. I say 5, you say 16. If I say 5 again, you're still saying 16. What about this guy? Yes or no?
No.
Okay, so give me an X that's going to have 2 different Y values. If I say 1, you would say 8. If I said 1 again, you'd still say 8. Okay, every X, if I say 3, you say, I'm not figuring that out in my head, but you should, because you should practice that rocket math all the time. 3 squared is 9. 9 times 2 is 18. 18 plus 6 is 20. Yeah, every X has only one Y value. If I looked at this graphically, and eventually this is something you're going to be able to do, it's going to look something like this. It's going to be up here at 6. Okay. And every X, as I move across the axis, has only one Y value. And that's what's going to be down here. You're familiar with something called the vertical line test, if you can look at the graphs. So is this guy a relation? Yes. What about this one? Number 6.
Yes.
Yes. That is good. What about number 7? Folks, I need to pause for 1 second. Okay, sorry about that. Number 7. Is this a function? Well, the answer is going to be no, because we're going to be able to put in and we would get different Y values. And actually, as much as we know the graph of Y equals X squares is a parabola up, when I look at this graph, instead of going holding water like it does, this guy is either going to be a C or a backwards C kind of shape. And you'll see down below when we talk about it as well. And once again, number 8 actually is a function, not a relation, something that you really don't have to worry about. Okay, you know the vertical line test goes back to the same thing. Is it a function? Well, let's see. Is it a function? If I give you the X value of 2, I go, oh, there's one Y value. There's another Y value. This guy is not. That is not a function. This guy, every X, as I move left to right, has only one Y value. This guy, Ryan, is it a function or not?
No.
Why?
The vertical line would pass through 2 points.
Right. If I say 0, you're -1 or -5. We're not really sure there. So that's a problem. I just happened to hear him say that in his group. 2 of the 5 groups were actively learning. That's what we're going for. Second page, starting to work with function, what's called function notation. None of this looks exciting or looks important, but it's all building blocks for later. So here we're saying, okay, f of x equals some equation. It's a quadratic. The point here is wherever there's an x, I'm going to put a -3. So this is going to become 2 times, wherever there's an x, I put a -3, minus 3 times -3 plus 1. Did someone get an answer for that? Were you able to simplify that?
I think I got 28.
Excellent. That's the correct answer. The next one, wherever there's an x, I'm replacing it with square root. So this is going to equal 2 times the square root of 2 squared minus 3 times the square root of 2 plus 1. Square root of 2 squared is 2 times 2 is 4. Looks like I'm going to have a plus 1. So that's going to become 5 minus 3 square root of 2. Couple things as we go through this. You notice what I'm doing with my answers. I'm boxing them in. Do you notice what it's like with all of these problems? They're all numbered. And the reason I bring this up is some of you folks with your test work, you just scribbled stuff all over the place. And I can't find it to give you partial credit. So make sure you number your problems on your scrap paper when you're taking a test. And then let me see where the answer is. It helps me out considerably. Replace x, this time with capital A. 2 capital A squared minus 3 capital A plus 1. There's no simplifying that bad boy. Hopefully you got to D and you had a chance to work on it. Again, wherever there's an x, I'm yanking it out and I'm going to put in 3 plus z. 2 times 3 plus z squared minus 3 times 3 plus z plus 1. I'm doing that substitution. And there's a whole bunch of work there. I end up with z squared plus 15z plus 10. I'm hoping somebody else got the same answer. Can I get a hell yeah from a redneck girl? That was close enough. All right, 13. Wherever there's an x, I'm going to replace it with 3. This equals the square root of 6 minus 2 times 3. Looks like that guy ends up being 0. Again, rocket math. You know, I need to take 2 times 3 is 6. 6 minus 6 is 0. Rocket math. Oh no, that's Rocket Man. Equals the square root of 6 minus 2 times 4 equals the square root of -2. And we're cool with that. We know the square root of -1 is I. Well, not all of us, because some of us messed that up on the test. Plugging in -4. 6 minus 2 times -4. Rocket math. Square root of 6 plus 8. That's 14. Can't touch this. Final answer. Square root of 14. Don't even need to phone a friend. Square root of, wherever there's an x, I'm going to now put 2w. 6 minus 2 times 2w. Square root of 6 minus 4w. That's it. Club can't hold me. Determine the X and Y intercepts of the following functions. And as soon as I say find the X and Y intercepts, I'm hoping you're doing this. Gonna let X equal 0, gonna let Y equal 0. Gonna let X equal 0. Gonna let Y equal 0. I like X and Y intercepts, they're easy. Now, we don't see the Y here for this function, but you know when it comes to graphing this, we replace the function notation with the Y. So let's make each one of these equal to Y. Now, all I want are the X and Y intercepts. I put 0 in for X, what's Y?
-4.
Bam! I like it. I put 0 in for Y. Now, I'll have to do a little work here. X squared minus 4 equals 0. X squared equals 4. X equals
2.
It's a new language I just made up. How many answers are there here? A number?
2,
Yeah, and what are they?
+2 and -2.
Excellent. +2 and -2. +2. So if I had to graph this, I have 3 pretty good points to start with. 0, -4, 2, 0, and -2, 0. Sorry, I went all Tasmanian devil on you, but you probably don't even know who the Tasmanian devil is anymore. One of the coolest cartoon characters ever. 15. If I put 0 in for X, Y equals Hmm. 3 minus the absolute value of 0 equals Y. Absolute value of 0 is 0. 3
I mean
minus,
-3.
I
Go
think,
with 3.
yeah, +3. Okay, that's the first one. Second one is I put in 0 for Y. I'm going to add that to both sides. What number's distance from 0 is 3?
3.
And
-3.
3 and -3. Good. Good. Up here, if I put 0 in for X, I'm happy about that. 0 in for X, Y equals
2,
2. If I put 0 in for Y, I need to write this one. 2 minus the square root of X equals 0. I'm going to add that to both sides. 2 equals the square root of X. I get rid of the square root by squaring both sides. X would equal
4.
4. Awesome sauce. Awesome sauce. So pretty good practice there. Again, this is going to be a building block for what's coming next, but finding the X and Y intercepts. Oh my goodness, there's like 6,009 million pages. The domain. The domain is the X values. The range. The range is the Y values. This is my X and this is my Y. Looking at this graph, and it goes on and on and on. It goes on and on and on. I like that song. I throw my hands up in the air. What's the domain? If I move along this x-axis, what do I hit?
-infinity, infinity.
Yep. One way of writing it is -infinity to infinity. The other would be that symbol. That stands for all real numbers. That double back capital R stands for all real numbers. What about the range? If I'm looking left and right, where do my Y values start?
2 to infinity.
Yep, and including 2. So I can write it interval notation, Y is greater than or equal to 2, or I could do square bracket 2 comma infinity. I throw my head. Now I have that song stuck in my head. 18, domain. Moving left to right. Is there?
Negative infinity, infinity.
Yep, I'm gonna shortcut it. I'm gonna put all reals. Again, I said over here, we have that option. The range.
Be -10
And I
to
want
infinity.
that, right, Y is greater than or equal to -10. Okay, and again, there's 2 different ways we could write it there. This guy looks good, chugging right along for the domain. Oh, I have a little blip there, but no, at 1, I have a value, and that goes all the way out, but it stops this time. So the domain for this one is gonna be X is less than or equal to 4. The range, Y is gonna equal just 1. And then it goes from 2 to 8. 2 is less than or equal to Y is less than or equal to 8. Well, isn't that a cool way to write? Yeah. So my range values are gonna be 1 or something from 2 to 8. Again, that's my Y values. 20 is on there. It's just one for extra practice. We're gonna skip that one and move on. All right, this last page, put it all together. What, here we go. Use the function. Okay, so this is the graph of the function to tell me some things. What is f of -3? Well, I come in here and I go to -3, -1, -2, -3, and I come down, -1, negative. I get -3. F of 0. If I give you an X value of 0, right? If X is 0, what's Y?
Two.
2, correct. So I would have the ordered pair 0, 2 is what it's coming down to. Find all values for which, for X, for which f of X equals -1. This time I have the Y value, right? Instead of the X value, which is inside the function, I have a Y value. Where's my Y -1 for what X value? So really, this is what it's saying. If Y is -1, what is X? If Y is +1, what is X? So what X has a Y value of -1? Well, it looks like it's here. I think -1. For which X has a Y value of +1?
It'd be 1, 3.
Well, I'm looking for a Y value of 1. That's here.
Oh, Y value.
Yeah.
That would be the one, -1.
Well, here's my Y value of 1. I've come over to 2. So this guy is the 0.21. That was a little confusing, yeah. What is my x-intercept? Where does it cross the x-axis? Nowhere. None. None. Not 0. None. There aren't any x-intercepts Is there a y-intercept? Right, there's one. Yep, 2. The domain. They're both arrows. They go on forever and ever. All real numbers. The range. Oh boy. We have, okay, we have y values here. Y is less than or equal to -1. I'm going to put union. Union with, I go here and all the way up. Y is greater than 1. All the y's less than 1, all the y's greater than 1. Use for union. All right, that wasn't too painful. But holy cannoli, we have 3 sections of chapter 2 done already. We're almost done the semester, sir. I know. Well, maybe not. A lot of this is material that some of you had in Math 091. Some of you had it in Math 090. You would have had it in Algebra 2 in high school. So you may not remember it very well, but upstairs in the gray matter somewhere, this was located. And yeah, it was, okay. Standard form. Okay, little note there. This is called standard form. And the sad part is we hardly ever use it. We hardly ever use standard form. Most of the time, we're solving for y and making the equation y equals something. But graph the equation, identify the x and y-intercept. Okay, I know this is a straight line because it's x to the first power. I say 0 for x. You say, so that means this x term is gone. What's y?
-3.
Good. I say 0 for y. That means cover that bad boy up. What's x?
2.
2. So I have the point 0, -3. And I have the point 2. And I know it's a straight line. It goes on and on and on. I throw my hands up in the air. Okay. I can simplify this. If I start my chart, this has to be true. So what does x have to be? What does x equal?
-2.
-2. So x is -2, which means y is, I don't know, 4. But again, I still know x has to be -2. Y could be 0. It's still a true statement. And I could keep going on and on. X is -2, 0. X is -2, 4. And all of a sudden I get this vertical line. Oh yeah, that's like the vertical line test. Ah, so when my x's are all -2 and I pick, okay, so when my y is 2, that means my x can be anything and it's always going to be true. So I have 0, 2, I have 1, 2, I have 2, 2. I just never wear it out in public. Get it? No, I hate 2 2s. There you go. This is my horizontal line. Those of you going on to calc, you'll hear the term horizontal line a lot. You'll hear vertical. You'll also hear tangent line. Okay, yeah, I can dig it. Our third big formula. Our first one was distance equals the square root of x1 minus x2 squared plus y1 minus y2 squared. That came from the Pythagorean theorem. Then I had midpoint. That was one of our big ones. And that's a point. That was x1 plus x2 over 2, y1 plus y2 over 2. The word average comes to mind. My third one is something called the slope. And a lot of you have heard the term slope before. And the slope is the tilt of a line, how it goes up, how it starts at this point and it'll do a rise and a run. So if I start at this point, I would do a rise of 1, 2, 3. I would do a run of 2. This is rise over run. And some of you are going, yeah, I kind of remember that. I rise positive 3 and I run positive 2 and I have a slope of 3 heads. And again, you see this change in. This delta y means the change in y. Okay, the change in y from one point to the next, from here up. And then the change in x from where I stopped over. Well, it can be found by the formula difference in y's, or the change in y's over the change in x. So here, my slope, and a lot of you know it's the letter m, equals 3 minus -8 over x minus x. Looks like my slope is going to be minus a negative becomes plus a positive. 11 over -2 minus 1, -3. And hopefully you're okay with that. But we have the distance formula, the midpoint formula, now the slope formula. I'm not going to do number 5. Going to keep going on. Find the slope of the horizontal line y equals 4. So all of my y's are 4, right? So that means if I did this bad boy again, y is 4, y is 4. So this could be 0, this could be 1. 0, 1, 2, 3, 4. 1, 1, 2, 3, 4. Okay, so that is a horizontal line. I'm good with that. So I'm going to use these 2 points. Find my slope. Y minus y over, I get a slope of 0. My slope for a horizontal line is 0. Does anybody remember what the slope of a vertical line is? Yeah. 0 slope, horizontal line. If I came over here and I picked a couple of points, X and Y, -3, 0, -3, 1. And I want to find the slope, 0 minus 1 over -3 minus itself equals -1 over 0. And yeah, we can't divide by 0. That's a bad thing. That gives me something called an undefined slope. Okay, so a vertical line going up and down has an undefined slope because my change in x is nothing. You probably remember positive slopes. You probably remember negative slopes. All of that's good. All right. You know this guy, y equals mx plus b. I still don't like that. I like y equals b plus mx. And that's a whole nother story that we'll get into. B plus mx. And so, okay. Yeah, I got, okay. Use the slope and y-intercept to graph the line. Well, if I come up here, I know if I make this y equals, m is the slope and b is the y-intercept. Names they were given. Yeah, okay. But we just talked about the idea, if I start at one point, I can do rise and run to get to the other point. So for number 8, I need to solve for y. For number 9, again, I need to start the problem by getting the y alone. Hopefully you are being aggressive, and while I'm babbling, you are doing that, not waiting for me. That's kind of why I'm babbling right now. I'm hoping that you're getting the y alone. Okay, so I'm going to identify slope. Slope, you are 2/3. My y-intercept is -2. And it's enough to graph it. I go down here to -2. That is my y-intercept. Something we just talked about a moment ago. Rise of 2, run of 1, 2, 3. And I get the graph of that line. Are we good? So you notice how we graphed that. We started with the B first at -2. Then we did the rise and run. And that's part of why this is what I was saying, and we're going to build on that later. But B is important to start. The slope is what comes after. I'm going to add 2y to both sides. I'm going to subtract an x. That's still y. -x plus 4. Divide everything by 2. Y equals -x over 2. 4 to, I got that. I get an m equals -1/2. I get b equals +2. Oh no. So I start at 2. I go down 1 for my rise is -1 and my run is +2. I like it. I love it. Anybody? Nobody can finish that? I like it. I love it. Huh. What about this? Red Robin.
Yum.
Thank you. Phew. I was wondering if there's anybody out there. All right, I'm liking chapter 2 because I'm feeling, I got a feel for chapter 2 being, I'm not so bad with all of this. Write an equation of the line in slope intercept form. That's that's y equals mx plus b. I need to understand that first. Oh boy. Okay, so I'm going to do this. I don't know if I can pull it off or not, but point -2, 1, 2, +3, 1, 2, 3. So right there's one of the points on my line. That's kind of some good. Has a slope of 5. So I don't have my y-intercept this time, so I'm hoping something good pops up for me. So I graph that. Slope is 5. But I know I like it as rise over run. And oh boy, write an equation of the line of all of that that passes through -2, 3, and has a slope of 5. So what is it I'm missing? I have a point, right? And a point is X and Y. I have the slope, and I know the slope is 5. So they're giving me some things. And I need to come up with this equation. And when I look over there, I say, ooh, maybe I don't need the graph for this. Because what if I say, well, wait a minute, when x is -2 and y is 3 and my slope is 5, I have an equation with one unknown. And that one unknown is going to give to me what I'm looking for, my b. 3 equals -10 plus b. Add 10, 13 is b. So now I found the other part that I needed for my equation. A little bit different. I looked at And this is part of solving a lot of problems. What do I have? And as soon as I start writing everything down, at some point, maybe, yeah, okay. So I want this equation. So y equals 5x plus 13. Yay. Some of you may be saying, well, I would have never come up with that on my own. Maybe you would have, but now that you've seen one way how to do it, that's good. So we're going to look at all kind of graphs throughout the semester. And this is really where algebra comes into play. You know, I'll still go back to starting out with plotting data. And if my data falls something like that, you may say, uh-oh, that kind of looks like a straight line. And we could make predictions and so on. And that's why we came up with study of lines and study of U's and study of all these different shapes, because we can create functions to describe what's going on. But if you take a look up, I still can't see it. If you take a look up here, the average rate of change. Well, the average rate of change, you know, so what if I didn't just have a straight line, but I want to know what the change is from this point to this point? And I'd like to find the equation of that line. And here it is. The average rate of change is the slope. But some terminology is coming into play that down the road will help you in this course and other courses. A secant line. This is the secant, right? Goes right on the inside of that, yada, yada, yada. It's called a secant line. It's under the arc. And again, we're finding the slope. So I'm not going to do the work. You're going to do the work. I'm going to sit back and relax. Number 11. What is the average rate of change? I say average rate of change. You say slope. Average rate of change, slope. Sometimes I feel like I'm here all by myself. The average rate of change. That's that guy right there. It's that secant line. So if we were describing something, you say, the sales were here and then sales went up and came to there. And we could say over that time period, the average sales was, and we would use 2 points. We would do the average rate of change. Answer is?
-3/5.
-3/5. Let's see, I'm going to say y minus y over x.
I copied the numbers wrong, so that's definitely not right.
Okay.
Right. I just noticed that.
So I did the second one first. 2 minus 0 over 0 minus that. She said, get rid of that. I get 2 over 1.5. If I double this, multiply top and bottom by 2. 2 over 2 is the same as 1. I get 4/3. I like it. I love it. Somebody have an answer for number 12? I love it. I like this because from here I go and yeah, okay, yep, I like it. Questions? Oh boy. Nah, not a no boy. Oh, good. Let's put it that way. Oh, good. The last page. Use the graph to solve the equation and inequalities. Oh, yeah, hey. I'm going to pause, give you all about 30 seconds to try this on your own. So some of you may be doing the pencil pusher and trying to figure it out, but it looks like they want me to use the graph. And if I said, oh, y equals this in blue and y equals this in red, and now I said, oh, when does the blue line, we're talking hockey. No, here's the blue line and here's the red line. That's over in York County, isn't it? Red line. Get it? Sorry. If I have a blue line and a red line, and I want to know when they're equal, at what X value are these two equal?
I got 2.
I got 2 as well. Very good. So you're telling me if I would have done all of this work, I would have gotten 2. Well, what's half of 2 is 1. 1 plus 1 is 2. Good. 3 times 2 is 6. Minus 4 is 2. 2 equals 2. Yep. I got it. Good. When is my blue line? It's y values. When are the blue lines y values less than the red lines y values? When is the blue lines y values less than the red lines y values? When x is
It'd be less than 2 as well.
I want, when is the blue line smaller than the red line? So these y values are now smaller than these red line y values. So I'm going to say from this point on, the blue y values are smaller. So when x is greater than 2. And then here, when are the blue y values bigger than the red y values? Well, it looks like if I'm anywhere to the left of this point right here, the blue y values are bigger than the red. So when x is less than 2. That's just a different way to look at it. Instead of doing all the work, the graph is already done for me and I could come up with that. Please don't be another page, and there's not. So with that being said, that there is